There we go. All right. So we're going to start talking about something called the sampling distribution today. I think some of you guys noticed there's been O beads. They're not technically beads, but they function as beads. Okay. And what are some things that jump out at you about this? A lot of red. Some yellow, some white, and a whole lot of red. How much red? So most could be like slightly over half. Heck, when you have 3, it could be 40% red, right? Because that would still be the most. Wait, yeah. Could still be the most at 40%. It could be like 40, 30, 30. And it would still be mostly red. Are you guys comfortable saying 40, 30, 30? No?
I'll go 60, 20, 20.
60, 20, 20? All right, can we assume the red and the yellow are the same?
Wait,
There's
what is in there?
BBs.
No, like
It's a box.
it's a rectangular thing.
It's a box. It's the
My random sampler, of course.
Got it. That's actually kind of
Thank you. Thank you. Those of you who want to laugh at me. Different sampler. Are we good? I could do this all day. The amount of times I've had this out where people just start going like this, like it's hilarious how much people enjoy it. Should I take a picture of this for people at home? All right, so population. Yeah? This is my population.
having trouble there.
Yeah, I was having some trouble there. Sample. Yeah.
not the whole thing's full.
It is full.
There's a couple extra empty spaces.
Those are white ones. Yeah, those are white ones. The reason I had to go back a couple times is that it wasn't full. But yes, that wouldn't matter. Okay, you guys. Does anybody feel like figuring out what percentage of this is red? You want to count all these out?
I will.
Yeah.
Well, you're not going to because we don't have that kind of time. Okay. Do you think it would be better to figure out this percentage or this one?
That one. Not this one.
That one.
Does this seem like a representative sample?
Yeah.
Are you comfortable with saying these are very well mixed?
Yeah.
They better be because I've been doing this. I've been curating the randomness of this mixture for 6 years. I've been well mixing this mixture. Cool? Alright. Now, so we're going to spend a lot of time talking about how samples behave under known conditions, though I'm still not going to tell you what percent of this is red.
70% red.
So, you guys. If I take this sample of beads, it has 18 red over 33 total. So according to this sample, it's a row of 6, then a row of 5, then a row of 6, then a row of 5, and then
I wasn't expecting 33.
I understand.
Like a 36.
I understand. There's a percentage associated though with 18 out of 33, right? 0.54 repeating. So are you guys comfortable with me saying that according to that sample, the percent red of my population is about 54%? Okay. If I were to take another sample, is it possible it would have a different percentage?
Yes.
This one's 24 out of 33. Teddy's on it. 0.72 repeating.
How do we know you're not lying to us?
Because I know how to count. What possible incentive do I have to lie? And also, if I wanted to lie to prove my point, I would not have picked 0.72 again.
Is that credibility?
Okay. That's a 1 repeating, not a T. Yeah? Okay. So you guys, how come? Because every single time I followed the same process, right? Basically, dip, mix, count. You guys with me? So how come even though I did the same process every single time, I did not get the same result?
There's variability in like where the beads are when you put the thing in, and like where you move the
'Cause-
surveyor.
Yeah, it's random. Yeah, these were truly random samples. And if we have a sample that is truly done randomly, randomness causes differences amongst the samples. Not crazy differences, but differences. So the first lesson of Unit 5, and I can't emphasize this enough, is
samples are not perfect.
samples are not perfect. And everything we're going to learn for the rest of the school year, and I genuinely mean that, everything for the rest of the year is going to be how do we somehow work with these imperfect samples to make conclusions about a population. Everybody okay with this? So the reason
Samples are not perfect.
is put on a button is because we're going to say it a lot, and I just need to protect my vocal cords because I know you guys love the sound of my voice, and I want to make sure you get to hear as much of it as possible. Okay? All right. So maybe start getting this idea of samples are not perfect. In your head would be a good thing. Because it's the reason we do a lot of things. Okay? If we have time at the end, remind me to tell you the story about when I cried. About a student recognizing samples are not perfect. To a point that it brought a tear of joy to my eyes.
Was the student like so bad that you
No. I'll tell you the situation if we have time at the end. Okay, so are you guys with me? One last thing about my bin here is, like, if I could I make a dot plot of all of these different percentages that we got? Yeah, it would look kind of like this. Here's my 0.51, 0.54, 0.72. We'd have one, a whole bunch of these. And if we continued this out, are we going to get some samples upwards of 80, 90%? Yeah. And so as we make this graph, we can keep going and keep going and keep going, what do you think that graph is going to start to kind of look like? It's going to start looking approximately normal. So, knowing that, we need to think through some of the more nuanced ways I could ask you about the normal distribution. Cool? All right. So, let's practice some normal stuff. Yeah, he's here even when he's not here. It works really well. Yeah. So, let's kind of work through some of these examples. We're going to go through these examples and just a few things on the next page, and then we're going to be done, and you'll have some time to work on test corrections. Okay? So, what do you guys remember about z-scores?
It's like how far away they are from the mean.
Number of standard deviations from the mean. And we have both positive and negative z-scores. Positive is above the mean. Negative's below the mean. Does anybody remember the formula in terms of how we would calculate the z-score? The observation, whatever that number is, minus the mean. It tells us how many, first we find the distance from the mean of the point, okay? And then we divide by the standard deviation to figure out how many standard deviations that is. Okay, so how we wrote it before was x minus mu over sigma. Okay, so as we talk about this, we have that the mean is 1.34. The standard deviation is 0.25. And if I want to know the z-score of a hazelnut that weighs 1.56 grams, I would do 1.56 minus 1.34 over 0.25. .88. Okay? And you guys, does that mean that this is a really big hazelnut? Moderately big hazelnut? Moderately big. How big would it have to be really big?
2.5.
The typical rule of thumb, more than 2 standard deviations from the mean is unusual. Okay, anything within 2 standard deviations of the mean, it's like, yeah, it's on the big side for sure, right? So,
Wouldn't that be 98%?
95%. The middle 95% would be 2 standard deviations from the mean. Is 3. Okay. Everybody good so far? Some more reminders of the normal distribution. What weight would the 30th percentile be? Well, now we're using the fact that it's normal. I'm going to label my mean. I'm going to label my standard deviation. And why I put 2.4 instead of 2.5, I do not understand. Okay. And what do we know about the 30th percentile? It is larger than 30% of all the observations. So if I asked you guys, pretend I'm stupid. I know it's going to be a challenge for you, okay? I know it's challenging to pretend that I am stupid, unless we're talking about, anything other than math, okay? And if you had to tell me to draw a line where it would be, where would you say?
Towards the left.
Towards the left? Well, that's a pretty big range.
A little more than a quarter way through the graph from left to right.
Are we comfortable with that?
Yes.
Being the 30th percentile? Cool. And do you guys remember how to find this? You got to put it in your calculator? I don't know. Remember, I'm not very smart today.
It's the normal CDF.
See, this is fun for me. Yeah. I get to learn so many new things since I'm so dumb at math. Can somebody tell me how to find it? How is inverse, how is the normal CDF and the normal PDF working out for you guys?
Not well.
It's not working out well, yeah. I might not pick the one that I can't seem to find. If you do the inverse norm, what is the inverse norm asking you for?
The area of the curve.
Huh, do we have an area?
Yeah.
Oh, so we should use inverse norm of 0.3. And then it asks you for that weird symbol that's attempting to look like this symbol, the mu, the Greek M, mu for the mean. Right? That's going to be the 1.34, and then the sigma is going to equal 0.25. And you guys, do you think I could get close? I think that's roughly a little more than one standard deviation. I'm going to go 1.19.
1.2.
You guys, that's terrible. I should do way better than that.
Yeah, you should.
I should be way closer. Everybody good? Do we get the basic premise of this? Okay. What range of weights contains the middle 90%? That's a good looking normal curve.
I don't know after all this time.
Okay. You guys. I know some of you have fancy calculators. I also know that some of you do not. I'm going to do this with the unfancy calculators. Okay? You guys. What is the area of one tail? Why is it 0.05? I agree with you. Because there's two of them. And combined, what do these two things need to add to? The other 10%. Yeah? Is everybody good why these are 0.05 and 0.05? Okay. Those of you with the newer ones, you guys probably have center as an option when you do inverse norm. You guys can just do center. If you don't have one of those ones, your calculator only thinks left. So if I want to know this boundary, I'm going to give it 0.05 because it'll give me, because it thinks you're shading to the left the whole time. All right, so what is that lower boundary? The lower, just the lower one for now.
0.05.
No,
0.9.
0.93 grams. I agree. Because I want to know what is the boundary, not where is the boundary. Okay. And then if I had to use the left hand, what would the area to the left of the other boundary be? It would be 0.95, and then you could use that 0.95 to find the upper boundary. 34 plus another 7 is 41. 1.75? Great. Awesome. Let's look at this next one. The running times of movies are normally distributed with a mean of 102 minutes. Aladdin at 92 minutes is the 23rd percentile. And the question is, what is my standard deviation? It's when you do what? So, all those functions in your calculator, you need to know the standard deviation, right? So, what you have to do is use that normal distribution in your calculator and find the z-score of the 23rd percentile. things I know about this, it's going to be negative. How do I know it's going to be negative? Because it's below the mean. Negative z-scores can totally be negative. That just means they're below the mean. You guys, what are you getting?
-0.468.
Cool. Are you sure you didn't get? No, that's not right. It should be like negative 75%, 0.75 or something.
Oh, I said 3, 2, not 2, 3.
7, 3, 4. Not a big deal. Okay, you guys, that means if we use that z-score formula, we can say 92 minus 102 over the standard deviation has to equal that negative 0.738. Cool. Now, theoretically, none of this has been new. This isn't new. We've done this, yeah? Just need a quick refresher. See, Anagrasa, by telling you to remind me, I remembered. All right, y'all. So, Unit 5 has very few questions on the AP exam. Very few. However, it is the foundation for Units 6, 7, 8, and 9. And Units 6, 7, 8, and 9 have tons of questions on the AP exam. They equate to about 40% of the test. Do you guys get what I'm saying? Okay. So there's not many questions I have to source from for Unit 5 that are like AP style questions. Okay? So for Unit 5, Unit 5 is going to look different than a typical unit that we've had so far, right? Okay? So for this unit, you're going to have one quiz for which the yellow sheet is your review. Everybody good? You're going to have 2 homeworks over the second half of the unit. It's more like the second third and the third of the unit. You're going to have 2 homeworks over that. Then you are going to get a quest. Half quiz, half test. Okay? Do you guys get what I'm saying? It is not worth anywhere near a test. It is going to not be AP questions, therefore not graded like AP. You won't get the curve. But you guys, how frequently have you felt you needed the curve on a quiz? It is going to be just like 2 quizzes added together. Think of it that way.
There's going to be less nuance.
There will be very little nuance.
Wonderful.
Very little nuance. Yeah.
Throw the nuance button out the window.
Nah. I mean, we're going to use it in about 2 minutes. So, nope. This is not the nuance button.
Get it up.
It's right here. This one can almost permanently stay here now.
Which one is that?
Well, you'll find out. You guys need to have a little bit of patience.
Okay.
A little bit of patience, okay? All right. So the quiz is going to be 12-8. The quest is, I think, 12-15. No, because the midterm is definitely that Tuesday and Wednesday. I'm pretty sure it'll be 12-15 will be the quest. Okay? And then the midterm the FRQs will be on 12-19. And the multiple choice will be on 12-20. You're doing the FRQ first specifically so I can grade them while you take the multiple choice. because it's a lot easier for me to grade the multiple choice quickly than the free response. Yes.
This is sort of like way in the future, but do you know if we're doing an exam schedule at the end, like at the end of the year this year? Or
Like in May?
yeah.
I do not know the answer to that question. I believe the teacher leadership team will be having a conversation about that very soon, though. Pretty sure that's on our agenda for next week. That means we'll make a decision like 5 months from now. Everybody good?
I liked it. I did look at it.
I would, when you guys get the homeworks, I would recommend you work with each other on the homeworks.
There's
The free response questions have, I wouldn't even call them nuanced, but there's a lot of, they're very detailed. They're tough. They're challenging, for sure. Like I even wrote a note on top of the pile when I hand them out to you guys to give you hints. Cool? All right, so we're going to do a little bit of new stuff. It's not going to take long, I swear. Okay, we had our population. Are you guys with me? That the percent of this that is red is a constant number.
Yes.
Unless it takes a while, but yes.
And we would call it the proportion of red. But if this is my entire population, that the proportion of red is never going to change. Okay. Is the percent of this that is red meaning the same thing as the percent of this that is red?
That's the percent you're saying.
And is the percent of this that is red a constant?
No.
No, because if I took a different sample, it's a different percentage. The percent of the population doesn't change, the percent of the samples could. Yeah? Okay. So when we have a statistical measurement, we have percents of the sample and we have percents of the population.
What are you looking for?
I found it. It's here. But you guys, from my perspective, this blends into this really well. Okay. All right. All right. So percentage is like a number that we use to measure a group, right? Okay. It's one of several different things. If we're measuring these something of the population, we call it a parameter. And it's worth noting that this is usually a constant value. Okay? The other thing we know about most parameters is that we do not actually know them. Okay? Now, a statistic is a number that describes a sample. And it is usually variable because... Does anyone want to guess why?
Samples are not perfect.
The perfect sample, if there was such a thing, would match the population. Okay? But there is no such thing as a perfect sample. All right. So what we do, the practice of using statistics, and the goal of what we're trying to get at with Unit 5 is like kind of like what happens when we know our population, what do the samples look like? In the future, what we will be doing is we don't know the population, we have the sample, but we know how samples behave, and we make conjectures. Okay? Lastly, because of this, because there is a difference between the percent red and the percent red, whether I'm talking about the population or the sample, we need to use different symbols so that we know which one's which. Okay? All right. So, for instance, the proportion or percent of a population, we use the symbol P when it is a population. When it is of a sample, we're going to use a new symbol called P(). hat. Yes, we call it p hat. Okay. The mean of a population is that curly Q mu. The mean of a sample is X bar. So you maybe have been wondering why sometimes I use X bar versus mu. The answer is X bar talks about samples, so when we're finding the mean of a set of numbers that we have, it's an X bar. When we're talking about, say, a distribution that we know is normally distributed, we're describing the population, then that's why I've been using mu. Okay? Population standard deviation is sigma. Sample standard deviation is S. Now, there's plenty of other parameters / statistics that go together. These are the ones we're going to be focusing on for the next few months. I'm done.